So good morning all together. Thank you for your time this morning and thank you for spending your valuable time to listening to my presentation. Just to introduce myself quickly, I'm Markus Pennekamp. I'm the Executive Vice President of Sauersig Group and the Albrecht Group and Polytype Group, which we now merge into a new name, which is called Matthews Engineering. Why Matthews? Because we are a subsidiary of an US-based company in Pittsburgh. And we want to go forward with this name into the future. The presentation is about innovation. It is about technology. It is about what we developed, and it is about transformation. I think that's what the complete industry is in. I want to kind of start with some kind of feedback, if you allow me to do that. The organization here, or the conference, is really greatly organized. It was yesterday a great day. Today will be a great day. The first talks here were great. The dinner was great yesterday. But I got some feedback during this networking sessions yesterday evening, and I want to share that a bit with you. I was a bit surprised about that there was so much complaints about regulations and the government doing not the right subsidies and these kind of things. I think that's not the right way to go into this future, because all of you, most of you, I guess, are sitting here because of the fact that we are now in an industry which is, as a colleague of mine says very often, we invented that, what I just will show, it's foundation time. So we are in an area where things get new, right? And we are in an area where we can shape markets when we do that. And I'm again a bit surprised that we complain about the circumstance, because all of you wouldn't be here if the governments wouldn't have changed their ways to be in 2030, 2035, or 2040 decarbonized in the end, right? So that's just a feedback from my side, as some people were asking me if I can say that today. Just present our company a bit, and that's really quick. We do come from a complete different business. We produced over years. We were founded in 1953 by the Sauersig brothers. One of them is still alive, 94 years old, a very great guy. To actually produce, at a point of time, textile screens, gravure cylinders for the printing industry. So we produced thousands of cylinders a year for the printing industry. We provided gravure cylinders in a high quality and embossing cylinders in a high quality to the tobacco industry. Totally different thing. It's nothing to do with battery. That's a totally different thing, and we had a small kind of, if you will, department, which of course was building machines, calendars for the tobacco industry, for example, or for the packaging industry. But then I think it was 6-7 years ago, some colleagues of ours in the R&D department, one of them is here today, Thomas Hackford, he with colleagues invented a process for the dry battery coating process. And he did that in a way which was very fast and agile in my point of view. And that is, again, that is already 7 or 8 years back in time. That was small in that point of time. And this is also about transformation, because of the fact that my former boss, I'm an educated MBA, I have an IT background, I have no idea about mechanical engineering, I have no idea about chemical engineering. My former boss, who was a doctor of physics, PhD, he didn't believe in that. He just didn't believe that the battery industry will grow. He didn't believe in that technology. And finally, in all honesty, he was kicked out by our shareholders in the US. And as there was no one there who did fast enough run away, I took over that seat, and having no idea about the technology as such, but I learned a lot. What I mean is, that is all about transformation and trying to get these changes and opportunities. So we come from, as I said, packaging industry. We do build machines now in the meantime, of course, for the energy industry. So we do build battery calendars for a lot of battery producers. You know all the names of them. We produce, at the same time, machines for the coating and converting industry. So we also produce machines for the coating process, primer coating for the battery industry. We produce still rollers for even wallpapers and for tissue papers, these kind of things. And we also have an area where we supply products and services in the warehouse automation field. I did put a quote in there because of the fact that, again, I do think that this complete industry is currently at a stage where If we wait too long, we don't come forward, right? So that is really the secret in my point of view, just do things, go on. Again, this is a bit more about technology and innovation. And this is a quote from Mark Twain. So just start with the things, right? And I had to put in a quote, if you will, from my colleague Thomas. He says always, let's do Scrum, let's do Agile, let's do rapid prototyping. Think out of the box and go the extra mile. That's what he does. You will see that in the presentation. He does that with his team. He doesn't do big exercises like first do, I don't know, 6 months of analysis in a way. He just starts and do things. And with his team, of course, there's great people around that one across the globe. But with that one, we really are very quick in developing new technology for the battery market. What is for us the battery market, right? With the battery foils and the coating process. Some numbers, not that much. I think it's all of you know that the battery industry will grow in the next years. All of you know what is possible in the market. I guess until 2030, if it will be 5,000 gigawatt, 6,000 gigawatt, or terawatt, or it will be 10,000 gigawatt whatsoever. I mean, Elon Musk says that he thinks Tesla by itself will be at that point of time with I think 3,000 gigawatt of production capacity. So that's huge numbers. The process as such between dry battery electrodes and wet coated electrodes. So we discussed it yesterday, I think, a bit, and I like the one statement where it was said that there will be different technologies coming up, of course, and there will be not the one, but the one which we, if you will, currently invented as far as it goes now and as it is industrialized. We do know and have seen that now out of different analysis with customers that the total investment reduction is around 70%. So you spend 70% less in CapEx if you use that technology to produce a dry battery film. 70% less. You have almost 1/7 of the space you need. You reduce your labor by 75%. Yesterday there was a lot of claims about high labor costs in Europe. You can come around this with innovations, with new ideas, with changing technologies. That is where you gain productivity, right? And this is what you get with the dry battery process. You have 75% reduction in utilities. So you spend less in energy. You consume less energy. You have less waste, less water consumption, all these kind of things, which in itself is also, of course, environmentally friendly, if you will. And you also eliminate toxic solvents, and you improve the battery performance. And there was also discussion here around you enable your customers, which is ours in the end, which are the battery producers, to build out the gigafactories faster, much faster. So that's really a competitive advantage with this technology. And we have, as mentioned, developed that. And we are at a stage where it is industrialized. What I am allowed to show is where we are at with our, or where we have been with our development in the past years. So these pictures you see, they're in brackets, if you will, unfortunately quite old. They are from Thomas 2016 or something like this, I think. Right. Thank you, Thomas. They are old. They're 7 years old. We were at that stage already there to take a dry powder, put it into our lab assemblies or lab lines, and then produce a dry film with that. And it is working. And with that one, you see that's a kind of an R&D setup. But with that, we were able to produce the first windable material, which is made of this, which is made of this dry film, and that has confirmed that this works. And of course, it was a foundation for further developments. Again, this is 7 years back in time, so it's not that we sat idle in the last 7 years. We went forward and developed further and improved and improved and improved, of course. These are then kind of a multi-role calendars, which we sell to interested battery manufacturers or companies which are working in that space. A lot of the people which are here, I guess, some of you have maybe bought one of those from us. A lot of people which were on the stage here, sure also bought one of these lab lines from us, and they do the tests in their R&D labs, because we do not formulate the recipes of the powder. That's not our job. We are machine builders, and we build the machines in order that you can process your material. That's what we do, and that's what we developed in the last years to sell that to our customers, and then to from there scale it big. This is a video. I think it's also 5 or 6 years old. That is for the dry film process for bipolar plates. So we're working also in the hydrogen fuel cell industry. So we are trying to supply, if you will, both kind of battery markets, if you will. The battery which is produced into cells, if you will, and then the fuel cell related business. It's unfortunate without any toner or so. We are more machine builders. We don't have that exhausted marketing materials available, so that's not a part of our legacy and part of our vein. So it is working, and it is working since years. And again, as we learn every day, we are improving that day by day. We are in the meantime at a point of time where we can provide our customers with what we would call middle-size lines. So it's a different width of the rolls. Normally these are then 12 to 14 rolls, and you get out of this anode material, if you will, or anode-based dry-coated films and cathode dry-coated films. We also sell lines in the width of 1,600 millimeter of the rolls, and up to I think 100 meter of speed or so, Thomas, right? And this one line then can produce 25 gigawatt hours. So this is quite a lot. This is, again, I do think that, of course, I'm proud on the guys. I do think this is really something which changes part of our industry at least. So we enable our partners to scale up. A lot of people said this is not possible, but honestly, we just did it. It does work. Again, for confidential reasons, I'm not allowed to show the machines behind that, but it is working. I just can repeat that, and it's cool where we stand with that one right now. Just some of you, I don't know who are. There's a lot of different kind of industries all working into the battery industry, but if you're interested, just visit our website, which is www.sauersick.com, and then you can find the right partners. We are really, as we are working as a machine builder, we are flexible so we take, let's say, your demands, and we work with you together. We start from doing it in a lab scale, and then we can scale it up. We are your partners, and we are really, I think that what a lot of people ask for, we are quick and fast, and we are having now years of experience in the dry film process. That's from my side.
Thank you, Markus. We are a little bit ahead of time, so we have time for questions, and there are a couple of them. The first one is, and maybe we can see them also on the screen here on stage. The first one is, you said there will be different technologies in the future. For which applications will we see dry, and where will we see wet coating?
I think that we will see the dry coating for really the batteries which are produced today by the big players. Let it be, I think, Samsung, LG, maybe ACC, of course, because Jan Vincent was yesterday mentioning that process as well. I do think that they will not completely replace wet coating, right? But I think with the advantages I just explained and which are proven, the industry will change into that one, and that's my hope, of course, because we're in that, will set a standard. I do know, again, that's now my little bit lack of knowledge as being an IT guy, that this dry process is also the base for the further development of the solid-state battery, right? So this is just eventually only a kind of a transition technology in order to come to the solid-state process. Need a bit look here and there to Thomas, which is in the back there, because he is a brain behind all that. If he says yes, and I'm right. If not, then I have to take
Yes,
something.
I mean, you're invited to come here after the presentation. Maybe if we have further questions, you can answer them. Next question. What kind of binders are you currently using in the process? Would your process still stand if the PFA ban were to apply in Europe?
That's a good question, which I actually really can't answer. What kind of binders do we use, Thomas? Beyond PTFE, so something different is possible for that one as well.
Yeah, sounds good. And if you want to dig deeper into that, as I said, Thomas will be here.
Will
be around after the presentation. The next question. You showed many advantages of dry coating. How does dry coating perform in terms of OEE, which is overall equipment effectiveness, I guess, and yield rate compared to wet coat?
So again, as mentioned, you have less labor, you have less energy consumption, even you have less scrap and waste, because what you have seen in the video, what you take out of the left and right stripe, right, you can put it back into the process at the beginning, so you don't have any loss there. And we have proven that our machines do run 24/7. So if there is, if you will, kind of almost 100% yield, with that one, you are just have an advantage against wet coating. Even if you are there having 100% yield, as we have achieved 100 meters, you are, in my point of view, ahead of the wet coating process.
Mm-hmm. Are dry-coated electrodes designed with recycling in mind? Are binders required difficult or carbon-intensive to then recycle?
I think also that is more environment friendly, as said, because you don't need any adhesives, you don't need any additional liquids or whatsoever, right, which are more environmental, in brackets, if you will, unfriendly. So there is no really kind of dedicated binders required, because this dry process takes the dry powder, puts it into the multi-coloring process, and as it is dry, it then kind of comes out of the machine as a dry film in the end, right? There's not that much binders needed for that.
Mm-hmm. Could you talk about some results, electrochemical testing with your dry coating, besides just capabilities of the company?
Not that much, because of the fact that is not our core business. We produce machines and we help our customers with their materials to get them tested, but we are not in, and we want to stay away from that one because that's their IP and their knowledge. So no, I can't do that.
Mm-hmm. Understood. Adhesion between dry electrodes and current collectors could be a big issue. How would you tackle this?
I can't answer that one.
Thomas can answer afterwards. The industry is hesitant to transition from wet to dry coating production lines. In your opinion, what are the major limiting factors in widespread adoption of this?
I think this is more mental. We had, it's really more mental, I think, because of the fact that, on mindset, if you will, because of the fact that, as you can imagine, we get questions from different potential customers, right? Like the big ones, right? And I think it was, I give just an anecdote. 1 or 2 years ago, we were asked to give in a quote for battery calendars, and we sent that in, and we got a pushback that they were too expensive. Mm-hmm. What you need to know is, again, that per gigawatt hour, we are more cheap than the wet-coated process. But as such, of course, it was a reasonable amount of money you had to invest in as such, but if you would do it in the other process, it would have been more. The feedback was then, is this a proven technology? We said, yeah, it is. Do you have 10 years of mass production? No, we don't. And then they went away. And that's a bit, but I'm allowed to do that a bit. These are now the ones which claim that by 2027 they will have the dry process running. So this is a bit interesting. So I think it's a more mindset that we are, and that's what I meant, just go ahead. We are, in my point of view, a bit too reluctant to the new technology, And we are in a transformation, so we just need to go in some areas and not be always too let's say, skeptic on these new technologies, right?
Push forward.
Yes.
Next question is a Thomas question, which is the max speed of
No,
the
we are
or?
currently, so that is a development. So we were, as mentioned, we were at 50 meters, 70 meters. Now we have reached 100 meters. We do think that with that one we have reached the maximum at the moment, but you don't know when you push the limits, right? So that's where we are at the moment.
Okay, maybe final question. Have you tried to manufacture solid-state electrolytes with your dry film process? Is this something interesting for your company?
That's confidential.
That's confidential. That was a quick answer, so we can take another question maybe. What are the major challenges that limit DBE processing at cathode side?
It is in the material, right? It is a very hard material, so you get different kind of issues as it is a very hard material. That on the rollers you could have dents and these kind of things, but if you manage it and if you develop it, you come to a point where you are able to manage that process and to get it running in the end.
Perfect. Markus, thank you so much for being with us today. You and Thomas will be around in the next minutes for answering maybe further questions. Your applause.
Thank you.